Hello again. In the last class, we discussed a little bit about arrays, and we also discussed all the basic concepts of arrays. Today, I'm going to touch upon some further aspects of arrays, like multidimensional arrays. So we'll discuss how we can use arrays in 2 dimensions or 3 dimensions or n dimensions, and then we will discuss very important aspects of C++ language, which are called functions. Functions are the basics of any language. So for functions are you will be using functions in most of your programs. In fact, when you have already used a function like int main, main was a function, and everybody has used it already in your tutorials. So let us start discussions for today. So we begin with the multidimensional arrays first, and then we'll go to the functions later on. What are multidimensional arrays? See, why do we need multidimensional arrays? Like in the last class, we discussed about one-dimensional arrays, where you have several variables of similar type grouped together. So like marks of a student. So I suppose your marks in this particular subject. Suppose you have marks in your computer programming subject, and there are 100 students in the class. So for each student, I have one variable stored, and we will have 100 such elements for each student. So I'll store these marks of this particular subject in one-dimensional array of all students. All students will have different marks. But another possibility is that you will have to have all your 5 or 6 subjects marks are to be stored, and each subject has 100 such students. So each subject, you have a one-dimensional array of 100 students, and for each of the 5 subjects you have 5 such arrays. So if you want to club them together, then you need to use multidimensional arrays in such an application. And similarly, you may have 3-dimensional arrays or 4-dimensional arrays and so on. So what is a multidimensional array? It is an array which is an array of arrays. So each, let's say each row of one array is itself is an array of several rows. So it is, for example, a 2-dimensional array is a one-dimensional array of one-dimensional arrays, as I just explained you with the example of subjects and the number of students. Similarly, a 3D array will be a one-dimensional array of 2-dimensional arrays, and so on. That's how you go further. Usually a 2-dimensional array is used to represent items with the same data types in tables, in rows and columns. So 2D array is like a matrix. All of you are aware of matrices. So matrix in fact is a 2D array. So, and again you have to keep that in mind, that all these elements of this array or the members of these arrays are of the same kind of data types. All of them are similar variables. So an n-dimensional array will have n indices, and the syntax for its declaration is you have to declare an array. Again, in case of 1D array, you only had this much, the first line, but here you have just beside that you will have further square brackets, and depending on the number of dimensions in that array, you will have that many brackets. So data type, first of all you will mention what is the kind of data you are going to store in this array, then the name of the array which you will define, and then these will be the dimension of the array, what is the maximum number of elements in that particular array for a particular dimension. So expression 1, expression 2 and up to expression n, where each expression evaluates to integer value. This can be 10, this can be 100, this can be 5, this can be 6, but it has to be an integer value. So that is how you declare a multidimensional array. Now, each individual array element in a given multidimensional array is identified by its indices, as it was identified in this 1D array. If you remember, you have indices, and indices again vary from starting from 0, not starting from 1, but starting from 0. So for example, in a 2D array, A, let's say you call it A, An element is uniquely defined. Its individual element will be defined as Aij. If you remember the convention of writing matrices, Aij is the ith row and jth column element in a matrix. Similarly, in the multidimensional array, in a 2D array, the element will be called Aij, where I and j are in the square brackets, and they are the indices of the array element. And some couple of examples here how you define this. Suppose you are defining some coordinates which are real numbers, so you define them as float coordinate 10 10, and it will have 100 elements, 10 rows and 10 columns. Similarly, a 3D array can be defined if it is an integer type. Int value is the name of the array. 50 for first dimension is 50 elements. Each of these 50 elements will have 10 elements. Each of these 10 elements will have 5 elements each. So it is a 3D array. You can also have an array of characters. Suppose you are writing a line, 10 lines of 80 characters each. So you will have a char line 1080. So this the first example here. It defines the coordinate as a floating point array having 10 rows and 10 columns, which I have already explained. So this will have 100 elements. Similarly, this array will have 50 times 10, 500 times 5, 2500 elements, and this will have 800 elements. So that is how that is the maximum possible number of elements. It can have less than that, but that is the maximum possible number of elements. Now this is such an example. So these are the columns in an array, these are the rows, and mind your difference, just focus on the way the indices are numbered. So it is a 5, it's a 2D array which has 1, 2, 3, 4 columns and 1, 2, 3, 4, 5 rows. But these rows and columns are numbered as 0, 0th row, first row, second row, third. In fact, first row is called the 0th member, second row is first, third row is second, the indices is 2. For fourth row, the index is 3. For the fifth row, index is 4. Similarly, here column wise also you again number them 0, 1, 2, 3. So the last element, which is a fifth row and fourth column, which will be A43. So that is how you define these are individual elements in an array called A. First element is A00, last element is termed as A43 if it is a 5x4 matrix. How do you initialize more than one dimensional array? Like if you remember, we discussed how do you initialize 1D array. Now, in a similar manner, with a subtle difference, a multidimensional array can also be initialized. So what is this? Let's see this example. It's the only difference is a 2D array is always initialized row by row. The first row is initialized, then the second row is initialized, then the third row is initialized, and so on. You can either put these individual rows in curly brackets, or you can directly write them like in this example, int A22. That means it is a 2x2 matrix, so it will have 4 elements, and this is the first row. First 2 elements are first row. When these elements are all counted, then the second row start 3, 4. So it has 4 elements. This is the first 2 elements are first row, the last 2 elements are the second row. So here A is a 2D array of integer numbers whose maximum size is 4, and that is how these different indexes are defined here. The individual elements, so the A00 element will have value 1, A01 is 2, A10 is 3, and A11 is 4. So if you remember the last slide, you can always form a matrix for such an example. So this is the natural order in which the initial values are assigned. They can be altered by forcing groups of initial values enclosed within braces. So you can also say, suppose as I told you earlier, that individual rows can be forced to fall in individual body of these braces. So the first row is 1, 2. Since the third element is not defined, so that will be taken as 0 by the compiler. Similarly, second row is defined as 4 and 5 and 6, and the third row is defined as 7, 8 and 0. It's not 0, 7 and 8. See, you cannot leave, the computer will always start counting from the first element. Only the trailing element or the elements all which are left here on the right side of the group, they will be taken as 0. So the individual elements here will be taken as, this is A00 as mentioned here, this is A01, and A02 will be not be taken as 4, but A02 will be taken as 0. Similarly, A10 is 4, A11 is 5, A12 is 6 here. Here A20 in the next row is 7, A21 is 8, and A22, which is not given here in the initialization, it will be taken as 0. So the rule is, if there are not enough initializers available for a given row, first row, second row, third row, in this case first and third row do not have enough initializers, so the remaining elements of that row are initialized to 0. Not the preceding elements, only the remaining elements of the row are initialized to 0. Here is an example of say sum of two matrices and how the multi-dimensional arrays are written in the C++. You can go through this. This you can find in any standard textbook of C++. So there are three matrices here, A and B, and I am adding this A plus B as the resultant matrix as C. These all have 10 by 10 and it's a 10 by 10 matrix, both of them, and then there are integers m and ij. I defined 4 integers. I just say enter the number of rows and columns of matrices A and B. So it can be, at the most it can be 10 by 10, but of course you can have lesser number of elements also. You can, both of them, since they are added together, so they both should have the same order, so both of them can be, for example it can be 5 by 3. A and B can be 5 by 3, so C will automatically be 5 by 3. But only thing is, they have to be less than 10 by 10 matrix. So first of all, you input m and n, which is the number of rows in A and number of columns in A and B both. So now, after defining this, we enter the elements of matrix A through using nested for loops. For I is equal to 0, I is less than m, I plus plus. For each I, you will have another loop which will go for each column. For I is for the rows and j is for the columns. So I am inputting individual elements, and then I am also inputting individual elements of a matrix B, and then in the next group of statements I am adding them individually. So Cij element will be a summation of Aij plus Bij. Remember, they had to be written in square brackets, and so then I can get the output of these two matrices on the computer screen as, for again similar loop. So this is a whole thing, Cij and L. Only thing is, in this this will be given as row wise. For each row, for each column is being written, and each row will be written Cij, 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 and then after writing all these Cij, the loop will go to the next line. So that is how you can find out a sum of two matrices, and you can display them on the screen also. So this is just a summary of what we did in arrays till now. After this, I'll go to a very, very important aspect of C++, which is called functions. This is one of the most important part of any language. In fact, functions. See, if you compare yourself or myself or any human being as a variable which can store different kind of values in our, not as a whole, but as a whole we may be a very complicated program. If you consider ourselves as robots or artificial intelligence created by something called God, then or if you assume that we are in a computer simulation or we are in a computer game, our whole life is a computer game, then we must have memories. Yes, we do have memories. In that memories, we have variables stored. All our memories are stored there. And then our body carry some functions. It just carry out some functions. We sit, we stand, we eat, we sleep. These are all functions of our body. We think. So these functions are also defined in a language using variables, and what we do with such variables, those are functions. And combining all those functions, we make a whole lot big program. Functions are very, very useful things in C++. Okay, coming back to the pure theoretical thing, we say that large programs are very difficult to implement, and it's difficult to create also, and they create confusions. Therefore, what the initial programmers did, that they split these large programs into a number of independent tasks. Suppose if you have a program called human, a human or a man or a human can be described as a robot. Let's say a robot. It has a lot of tasks it can do, but if you have to divide all those tasks independently, like sitting is in one of the tasks, talking is one of the tasks, standing is one of the tasks, pushing is one of the tasks. So these are independent tasks which can easily be designed, implemented, and managed. And when you combine all these tasks, we make a whole program. This particular approach is called a modular approach. You form small modules in a program, and all those modules are combined to give you a bigger program. So the example, the advantage of these modular approaches, it makes large programs manageable. So for that purpose only, we modularize into subprograms. And these subprograms, these small subprograms which are independent of each other, but they carry out certain things, they are called functions, because it does something. That is why it's a function. It does something. So for example, a repeated group of instructions in a program, or like a loop, as we did in the last example, summation of a matrix, I can define it as a function. And then whenever a summation of matrix is required in a program, I'll just call this function. I'll just say, okay, come on, my brain sends a signal. Suppose I want to sit. Then my brain sends a signal to my body to sit. What is that? Sit is a function defined in my brain, and my brain just transmits this information to my compiler or whatever, if I assume that we are a robot or something. So that can be organized as a function. And it can be invoked whenever it is required or wherever it is required. Invoked means it is called, or it was lying there somewhere in my memory that what does sitting means. And whenever it is invoked, I will sit. So instead of having same pattern of code repeated, sitting may be saying that, okay, bend your legs and then go down by this angle to the chair. That is called sitting. But if I just have defined this function as a name sit, then I just have to say sit, and then you will sit. Suppose I have a function called come here. This is a function. Suppose if you are in my class, I just say, hey, come on, come here. What you will do? You will raise from your chair, walk a little bit, and then you will come to my table. So these 3-4 things are defined in that function. Come here is a function. And as soon as your brain receives this message, come here, this function invokes itself, and you just come out and you come to me. So that is the way functions work. A function is a set of program statements or a subprogram which can be processed independently. All these functions are independent because they are called independent functions, because all the variable names and the labels which are defined in the body of the function are local to it. What does that mean? That only these variable names and labels and all such things, what you do in that particular function, they are known only to that function. Outside that, they have no meaning. So they are local to it. All these functions are known to only to the body of that particular function. So I will just list some of the advantages of using functions. 4 such advantages are listed here. One is you can do modular programming. You can have small modules, and the finding out errors in a program becomes easier. So the debugging is easier because you just have to deal with a smaller part of the program to find out where the error actually is. and it reduces the size of the program. You do not have to write the code, same code again and again. Just write the name of the function. You call the function at a particular place, and it reduces the size of the program, and your program becomes reusable. One function I define in one of my programs, I can save it for further use in a different program. So it's the reusability of the program also is a very important part of the functional programming. Now, there are three important things to use a function. If I want to add a function to my program, these three components are necessary. It's necessary for all the functions. First of all, you have to declare the function. What kind of function it is? What does it return? Like you have seen one function, int main, and then in parenthesis nothing. So you saw I have declared the function as int because it will return something integer. This is called function prototype. Which type of function is that? So either you say declaration of the function or the prototype of the function. It's the same thing. It means the same thing. Then you have to define the function, that what does this function do. So that's the main body of the function when you define it. Or it's a small program basically. The definition of the function is a small program within in itself, which is called a function. And then towards the end, then it is stored somewhere, but it is still dead until you call this function in your program. You have to call it. You have to somebody should say, okay, come on. Come on is a function which is dead which is just lying there in your brain. As soon as someone say come here, you will just, the function is called, and then you will just follow the instructions. Okay, we'll take it one by one. First of all, the function declaration or the function prototype. This is the syntax for that. It has this type, return type. Remember int main, say int main blank. Int is the return type. Function name, which was main in that case, and the arguments. In our case, for the main, there were no arguments for that. So these are the parameters of the function. These arguments are called parameters, and these arguments are passed with their data types. Whenever you enter these arguments in the function, you also have to mention its data type. So one of the example is return type, which is int. So this function, which is named as my function, it will return an integer value, and it has two parameters or two arguments. Both of them are integer type. So that is how you define a function. In this case, in the case of function declaration, I did not mention what are the parameters. I am just mentioning their data type. So that you remember, in a function declaration, it is not necessary to mention the name of that particular variable. Only the type of the variable has to be mentioned, and how many variables are going to be passed to the function, those should be known. So that is how you define a function, or sorry, not define, but declare a function. Int my function, int. So it has two parameters, both of them are integer, and this function also returns an integer value. So this function declaration, it will provide many information to the compiler. First of all, it will tell the name of the function to the compiler. It introduces that, okay, in my program I am going to use a function which will have the following name. Then the type of the value returned is, and what is the type of value is being returned to the function, that is also mentioned. And the third thing which it tells the compiler is that the number and the types of the arguments, and these arguments are also called parameters, as I just mentioned, and which have to be supplied to call the function. If I want to call the function, then I have to supply these parameters. Suppose I want somebody to bring me some stuff, bring me a bag of say mangoes from somewhere. So bring is a function which has a parameter, like say I'll say bring that bag of mangoes. So bag is also a function which has a parameter mango, and this function is called in a function called bring. So I'll say bring a bag of mangoes. So this bring also has a parameter which is a bag. So if I just say bring, it does not mean anything because I have not supplied the parameter of that. What will you bring? What will your brain say? Okay, what did he say? When I ask you bring, then you'll say, oh, what did my teacher said? Bring what? So it has to have a parameter. So that is how the functions also work. So the number and the types of the arguments which must be supplied to call the function, this also is mentioned in the declaration. The name of the function is mentioned in the declaration, and the type of the value returned is also mentioned in the declaration. So the return type specifies the data type of the value returned by the function. If a function does not return a value, sometimes it also happens, it does not return a value, then we use a word called void. So void is placed before the function name. Void, then star line, and suppose the star line is a function which has no parameters, so nothing in this parenthesis, and it does not return anything, so it's a void. Void means empty space, so it's a void there. So void star line. What is the star line function? I have a loop from I equals to 1 to 20. You just output a star, so there will be 20 stars written there, and then there will be end of line. Since it does not return anything, it has already done its job, so it does not return anything, therefore the return type was void. So that is how the functions you can start making small functions. So the function declaration provides a blueprint of the function. Basically, it tells you, without telling the exact parameters, what are the exact parameters. It is sort of a blueprint. Every building has a blueprint map where should be the electricity switches, where should be the pipelines of the water, where should the AC placed. Now you didn't tell which brand of AC will be built, but you will just say, in my room there will be AC here. So that is a sort of a declaration. It's a blueprint of the function. Very, very important thing, this last statement. This you all have to keep that in mind. A function must either be declared or defined before being called in the program. Common sense, but many times when you make the program, you forget this. Before you call the function, it has to be defined. Makes sense. And before it is defined, it has to be declared. What this declaration and definition can be, suppose you have already defined the function, then you do not have to declare it separately, because in the definition its declaration will be automatically there. But before being called in the program, it has to be either declared or defined. Sometimes the definitions of the functions are given separately in different program. Then my program does not know what is the definition. Then in those cases, they have to be declared, that there will be a function which will be called in your program which is of such and such type. So this either be declared or defined before being called in the program. This is a very, very important stuff all of you should remember. Now second part is function definition, which I'll take in the next class. I'll stop here today. So we have seen today how functions work in C++ language. The basics of functions we have already discussed, and in the next class I'll be discussing about how different parameters are passed in functions, and for further details of functions. So functions are very important aspects of C++ language. So we are going to spend a couple of more lectures on functions. So we'll see you next time.